I'm Anil Kumar, and here is an application question for you. An object moves in a straight line with its position at time t seconds given by s of t equals to 8t minus t squared, where s is measured in meters. Find the velocity when t equals to 0, 2, and 4. So whenever you need to find velocity, in this case that means rate of change or the derivative of the function at more than one point, you should always find out the derivative at a general value at any arbitrary point a, right? So what we will do here is we'll find what is s dash of t, right? So let's find s dash of t, which we can say is limit h approaches 0 for s of t plus h minus s of t over h. Now in this particular case, 8t minus t squared is the expression. S of t plus h means that you will replace t with t plus h. So we get this as limit h approaches 0 for 8 times t plus h minus t plus h whole square. So that is the first term. Minus s of t means 8t minus t square. Let me write that in brackets. 8t minus t square divided by h. So now we'll expand and simplify the numerator. 8 times t means 8t plus 8h. That will give us minus t square minus, let's do negative of each term when you square and open it, right? Minus 2th minus h square. When you open this bracket, you get minus 8t plus t square. Okay, so that is what you get here, divided by h. At this stage, what you have to notice is that all the terms without h will get cancelled. So 8t minus 8t is 0, right? So, and what you're left with are the terms which have at least one h. T square and t square will also cancel. So this is very important at this stage. If they don't cancel out, that means you've done some mistake in opening these brackets. So you are left with 8h minus 2th minus h square over h. You see that? You can take h common. So you get limit h approaches 0, and you take h common, you get h outside. 8 minus 2t minus h divided by h. At this stage you can cancel h and h. So what you get is an expression for the derivative of displacement, which is limit h approaches 0. The numerator here is 8 minus 2t minus h. Replace h with 0, so you get 8 minus 2t. So displacement, rate of change of displacement, which is velocity. So that means the velocity, which is equals to rate of change of displacement, is equals to 8 minus 2t. Now the question is, find velocity when t equals to 0, 2, and 4, right? So let's find it out now. So when t equals to 0, then velocity means velocity at 0 will be 8 minus 2 times 0, which is 8. When t equals to 2, then velocity at 2 will be 8 minus 2 times 2. That means 8 minus 4, which is 4. And when t equals to 4, at that time velocity 4 will be equals to 8 minus 2 times 4, which is 0, right? So that is one part. And second important part here is the units. Whenever you do rate of change, displacement was in meters, time was in seconds. So the units for velocities will be meters per second. So include units in your solution. That is very important. So what you notice here is that velocity at 0 is 8, at 2 it is 4, and then at 4 it is 0. So it is kind of decreasing. Do you see that? So you can find velocity at other times also. You'll find that the velocity is linearly decreasing. So if you sketch this graph, that is an added exercise. So what you'll get here is, let me just sketch a graph here. Function is defined when t is greater than or equal to 0. It's a parabola which opens downwards, right? So you can say s of t, we can write s of t is equals to, if I take t common, right? If I take t common, I could write this as 8 minus t, right? So that means it's a parabola which is kind of opening downwards. So it is kind of like this. I'm making a small version of it. So if you see the rate of change at any instance of time, what do you notice? You really see at 0, we say it is 8 highest. At 2, it is 4, and at 4, it is 0, right? So here it is kind of horizontal, which you can see. So this point is 4. Here it is highest, and then kind of decreases all the way, right? It decreases all the way. And if you really calculate the other values, that means if you calculate velocity at 6, let us put 6 here. So 8 minus 2 times 6. You'll get a negative velocity here because it's going downwards. Do you see that? 8 minus 2 times 6, which is minus 4. It is negative, right? And at this point, it is 0. So the velocity will be, now in this particular function, maximum we can find, if I put t equals to 4, then I get 4 times 4, which is 16. So this is 16. So anyway, so my graph will be kind of like this. This is the graph for s dash t. Do you understand? Or the velocity. So it becomes negative thereafter. So it is decreasing at a constant rate. The velocity is decreasing at the constant rate. That is what it is. And that you get from this equation, velocity, right? So if you graph this equation, which is velocity at any time t equals to, we can write minus 2t plus 8. So 8 becomes your y-intercept. Slope is minus 2, right? So that is how the function will be. So sometimes you may be asked to sketch the graph of velocity and displacement, which you've done right now. So you could do that also as an extension to this particular question. I hope that helps to understand how displacement and velocity are related. Thank you and all the best.